Hi all, today starts our connection to graphing. It's going to be really cool to see how this looks when we start making connections between factoring and x-intercepts. So to start that process, let's actually look at this first example. It says factor y equals x squared plus 2x minus 8. I see that a is 1, meaning we have an invisible 1 right here in front of that x squared. So I know I'm going to be, just as a quick reminder, when a is 1, we're looking for factors of c that add to b. So here we're looking for factors of negative 8 that will add to 2. So if I see I have 8, maybe I look at 4 and 2. Remember that when c is negative, one of these values has to be negative, and I'm looking to add to a positive 2. So which of these two numbers will I make negative? Well, to add to a positive 2, we're going to make the 2 negative, which means this factors to be x plus 4, x minus 2. Starting today though, notice how it says y equals. We're going to be setting this equal to 0. We're setting this equal to 0 because we're going to start looking at the connection between what we have here and what's on this graph on the right. So what's nice is that when we have two things being multiplied and it's set equal to 0, remember that whatever value of x that makes this factor 0, 0 times anything is 0. And then likewise, whatever value of x would make this factor 0, 0 times anything is 0. So we're actually going to break up the two pieces. We're going to set x plus 4 equal to 0 and x minus 2 equal to 0 and solve. So here I would do what to get x by itself? I would subtract 4 from both sides and I would get x equals negative 4. From this one over here, it's x minus 2 equals 0. So to get x by itself, I can add 2 to both sides. That will get x equals 2. Now when I look at these two answers and I see x equals negative 4 and x equals 2, notice the connection to our graph. Here, I've got negative 4, and here, I've got 2. And if we look at our connection, negative 4 and 2, notice here are our x-intercepts. So what we actually just found are the x-intercepts. X-intercepts, which are also called zeros, are negative 4 and 2. Discussing the answer to this question, do you see any relationships between the quadratic trinomial and the graph? We can now state the factors can help determine the x-intercepts. Let's now discuss, I wrote that word zeros in parentheses, but now let's actually discuss what it means. So let's highlight that word zeros. Zeros are the x-intercepts of a function. By factoring, you can determine these two values. So let's learn how this is going to connect to sketching a graph. First, we will set the equation equal to 0. you want to abbreviate that, you can just say equal to and 0. This is important because these are functions. So we're now dealing with y equals ax squared plus bx plus c. So when we set y equal to 0, we're then able to go find x by factoring. So once again, when we set this equal to 0, we're actually setting y equal to 0 and solving for x. Next, we will factor the quadratic. After it's factored, we will set each factor equal to 0 and solve for x. Once we've found those two answers, we will be able to plot the x-intercepts on the x-axis. And last but not least, we will sketch the parabola using the sign of A. So if I have a positive A value, literally meaning A is greater than 0, it's positive, it means that the graph will open up. As we can see here, this graph is opening up. If I have a negative A value, the graph opens down. Let's now look at some examples. So notice it says here, factoring trinomials with a GCF. Just make a couple reminders up here. 1, that means that if I'm being told there might be a GCF, we need to look for the GCF. And if there is one, so if there's one, factor it out. Factor it out. Then find factors of C that add to B. So we're going to be bringing in our prior knowledge of factoring in A is 1 and bringing our knowledge of looking for a GCF. So for number 1, we will first look for a GCF. So I see 2, 6, and negative 20. So I'm not even looking at x because I see that this last term doesn't even have an x value. But looking at the numbers 2, 6, and 20, I know that all three of those numbers are divisible by 2. So we can factor out a 2. At the same time, we will set this equal to 0. So this will be 0 equals 2. And now let's decide what's left. Factoring out a 2, that will leave x squared minus, what's next? Well, I can ask myself, 2 times what gets me 6, and that's 3. X is still along for the ride. And then again, I'll ask myself, 2 times what is 20, and that's 10. Remember that I should be able to send this GCF back in and get right back where I started. So now let's actually get a line down our equal sign, because we have an equal sign now. It doesn't actually have to be that long, like so. So if we look at what we wrote up here, we looked for the GCF, and if there is one, we factored it out. We just did that. Now we're going to find factors of C that add to B. We're just going to pay attention to this quadratic on the inside when we do that. So right now I'm looking for factors of negative 10 that add to negative 3. Factors of negative 10 that add to negative 3. So please press pause and see if you can find those two factors. factors of negative 10 that add to negative 3. So I'm hoping that 5 and 2 are what we looked at. And I see that 10 is negative. So that means that I need one of these to be negative, which is good for me because to get a negative 3, this 5 has to be negative. 2 will stay on the outside, and we will factor this to be x minus 5, x plus 2. So now let's just take a second to go back and see what we've done so far relative to those steps that we wrote on the first part of our notes. We set it equal to 0. And factored out GCF. Next, we factored when a equals 1, which meant for us factors of c that add to b, which was negative 3, and now we're here. Next, let's go see what we're supposed to do. So we set the equation equal to 0, we factored the quadratic. Now notice it says set each factor equal to 0 and solve for x. So let's go do that. We're going to take each factor, so x minus 5 set equal to 0, and x plus 2 set equal to 0. This will get me x equals 5 when I add 5 to both sides, and when I subtract 2, I get x equals negative 2. So this was setting each factor equal to 0 and solve for x. What's that next step? What comes after? So we found x. Let's go look at our notes. We accomplished this, solved for x. Now plot the x-intercepts on the x-axis and sketch using the sign of a. So let's go see what that's going to look like. X equals 5. So I go 1, 2, 3, 4, 5 on the x-axis, and x equals negative 2. I have successfully plotted my x-intercepts, and then we need to look at the sign of a to know if this is going to open up or down. So my question is, what is a? Well, I know from my prior knowledge that this goes, let me see if there's a color I haven't used yet. I'll just go with red. A, B, C. So when I look here, I see that A equals 2. Is that greater than 0 or less than 0? That is a positive A. It's greater than 0. So positive A means that this graph will open up. It's going to open up. Which means, just drawing a rough sketch, we sketch this to open up, and we are done. This is exactly how numbers 2, 3, and 4 are going to go. So let's now take a look at number 2. Our first step will be to set it equal to 0 and check to see if we have a GCF that we can factor out. So it's going to be 0 equals negative x squared plus 2x plus 3. Do I have a GCF that I can factor out? Well, we need to recall when we were doing our notes that if we see we have a negative leading term, we can at least factor out a negative 1. So we do have a GCF. The GCF is negative 1. And now let's see what's left. Factoring out a negative 1 is not going to actually change any of these values. It's going to just flip the signs. Because if you ask yourself, negative 1 times what gets me a positive 2? The answer is a negative 2. Negative 1 times what gets me a positive 3? The answer is negative 3. Now that we have successfully taken care of the GCF, let's go look and see what we did next. We took care of the GCF. Next comes factoring when a equals 1. So again, we're just going to pay attention to what's here on the inside. So on the inside, I have x squared minus 2x minus 3. Please press pause. I'm looking for factors of negative 3 that add to negative 2. And, especially if we're working in pencil, we should all be working in pencil, take a shot at writing what the next step's going to look like. Please press pause now. So factors of negative 3 that I can use are 1 and 3. C is negative, which means one of these two numbers has to be negative. To add to a negative 2, 3 must be negative. So my result will be 0 equals negative 1, x plus 1, x minus 3. Now you might have written x minus 3 first. That's fine. These factors can be written in different orders. Remember, in multiplication, order doesn't matter. Like 2 times 3 is the same as 3 times 2. What's next? Now that we've factored, after we factored when a equals 1, we are going to set each factor equal to 0 and solve for x. So that's going to be x plus 1 equals 0 and x minus 3 equals 0. And this is the second time where we have ignored the GCF. So you might be wondering, well, do we set negative 1 equal to 0? Negative 1 is a constant. It does not, even though it's being multiplied here, we're not going to treat it as a factor that we can do something with because there's no variable with it. If that was negative 1x, then yes, we would set it equal to 0. But it's just a constant number, no variable, so we do not include it in this next step. Now that we've set each factor equal to 0, let's solve. How am I going to solve x plus 1 equals 0? Well, I see x plus 1, the inverse of adding is subtracting, so we can subtract 1 from each side. And we will get x equals negative 1. X minus 3 equals 0. If you're okay in your head saying, I can just say plus 3 in my brain and get x equals 3, that's fine. If it helps us to see it, definitely show yourself the step. Adding 3 to both sides, we will get x equals 3. Now that we have our two values, these are our x-intercepts. So let's plot them. Negative 1 and 3. Now I need to determine, will this graph open up or down? What do you think? What's A? What is A? Well, looking here, I see that A equals negative 1. Is that greater than 0 or, oops, A equals negative 1 is what I meant to write. Is that greater than 0 or less than 0? Definitely less than 0. We have a negative A value, which means that this is going to open down. When A is negative, it opens down. So I'm actually going to start my sketch down here, come up. I like how that looks. Nope, not that either. And my quick sketch is complete. As we move forward farther with quadratics, we will have more and more accuracy with our graphs, but today is just a quick graph using our x-intercepts and our knowledge of A. Moving on to number 3, these steps repeat. So as we get comfortable, if you want to press pause and give it a try, that would be awesome. What's our first step going to be for number 3? Well, I always want to check for GCF. So please make a decision. Do we see a GCF? Is there a value that divides 3, 33, and 54? Press pause and figure that out. The answer is yes. All 3 of those numbers are divisible by 3. So we're going to set this equal to 0, and we're going to work on factoring out a 3. That will leave behind x squared. 3 times what is negative 33? Negative 11x. 3 times what is 54? And again, you can use your calculator to help you out with that. go ahead and do 54 divided by 3. And we should be getting 18. Now that I have factored out my GCF, what comes next? I'm going to work on factoring this inside piece. So 3 is going to stay outside, and it's going to be, what is it going to be? Factors of C that add to B. So press pause, and please factor. I'm looking for factors of 18 that add to a negative 11. Please do not press play until you have factored this by yourself. So factors of 18, 6 and 3, but I see that I'm adding to a negative, so both of these would have to be negative, and that's okay, remember, because when C is positive, same sign, so either both positive or both negative. In this case, negative times negative gets me a positive, but when I add negative 6 and negative 3, I only get to negative 9, and I have to get to a negative 11, so that didn't work for me. What other factors of 18 might I be able to use? How about 9 and 2? Would that work? Again, both would need to be negative because I'm trying to add to a negative number in the middle. Negative 9 plus a negative 2 does add to negative 11. So I know that this is my winning pair. And to factor, it's going to be x minus 9, x minus 2. What comes next? We've successfully factored. We have our factors. We're going to take each factor and set it equal to 0. Here we will get x equals 9 when we add 9 to both sides. Here we will get x equals 2 when we add 2 to both sides. Once again, these are our x-intercepts. Please press pause and sketch the graph on your own. Remember that we're going to plot both x-intercepts and then use the sign of A to determine if this opens up or down. So plotting my x-intercepts, it's going to be at 2 and 9. 2, 3, 4, 5, 6, 7, 8, 9. And then I look at A. A is 3. Is that positive or negative? That is positive, so I know that the graph is going to open up. Our quick sketch is complete. Let's decide on the GCF for number 4 together, and then you are going to be on your own to finish it, and then we'll compare answers with each other when you're done. So first, let's make sure we set it equal to 0. And sometimes there might not be a GCF, but sometimes there is. So let's see. Negative 2, negative 4, and 48. Right away, I'm hoping that it jumps out at us that these are all even numbers. So at a minimum, they're divisible by 2. And that actually will be our GCF because here we have negative 2. I can't factor out anything bigger than 2. Because the leading term is negative, our GCF will also be negative. So we will be factoring out a negative 2. Let's decide together what's left. It's going to be x squared plus 2x. And again, I got that positive 2 because I asked myself, negative 2 times what gets me negative 4, and I get a 2. Or you could see it as division. Negative 4 divided by negative 2 gets me the 2. Same question, negative 2 times what gets me a 48? Or if I'm not sure in my calculator, I could do 48 divided by negative 2. The answer to both of those questions is minus 24. I now have A as 1, because again we have an invisible 1 in front of this x squared. So please press pause, and I'm looking for you to finish all of our work here and the graph. when you press play, the work will be complete as well as the graph. So genuinely, please press pause, take a couple minutes, and finish number 4 on your own. When you press play again, we will be able to check our work with each other. Press pause now. Welcome back. Let's see if we match. I got x-intercepts are -6 and 4, and when I looked at A is negative, so that told me it opens down. So I plotted my 2 x-intercepts at -6 and 4 and sketched a graph that opens down. This completes our flipped notes for this lesson, and looking forward to getting any questions you have on these on Remind and practicing these skills in our next class. Bye everybody.